Hello there and welcome to this course on data visualization with R. My name is Valentine and I'll be your instructor. In this course, we are going to follow the following structure. So we'll get started with learning about the learning outcomes of this course. After that, we'll get to learn about the various data visualization concepts that we need to take into account in order to get to do a project in relation to data visualization with R. We'll also get to learn about why we need to apply those data visualization with R techniques, as well as when we apply them. After that, we'll go into an in-depth reading that we have curated, and this reading will just expound those concepts that we will have talked about during the what, why, and when section. And it will entail actually going through the reading that you see on the screen. The idea is that you will have a solid understanding, theoretical understanding of concepts in relation to data visualization with R before now later on continuing into the practice work. After this particular reading, we have also prepared a quiz that should actually help you to just see how you were able to understand those concepts that you will have gone through during that particular reading. Once we have finished the reading and quiz session, we will go into the practice session and we will provide we will provide what is called an R Markdown. That's just generally a document that will contain R code as well as just information in relation to data visualization with R. The different concepts that we'll get to go through. So stick around for that. We'll also provide challenges that will enable you to just be able to fully grasp those concepts that we'll go through. In addition, we also provide a solution document, our Markdown document, that will have now the solutions to the challenges that we'll have given you. Once we are done, as part of the next steps, you will be required to complete a project that we will get to share. And this project will just again help you to see where you can put into practice in relation to the real life, in relation to real life scenarios. And you should be in a position to apply those concepts in the scenario that we're going to give you. So what you're seeing on your screen is actually a project that you get to work on. We've also provided some guiding document that will give you just a good idea of how you can be able to start working on the project. And also we've provided a sample solution for that. So that's generally the structure that we're going to be using for this particular workshop. I can't wait to get started and let's do this. Right. So starting off, the first thing that we need to go through are the learning outcomes. So by the end of today's course, we should be expected to have achieved these learning outcomes. We should be able to recall data cleaning and analysis techniques to prepare data for data visualization. We should be able to outline the different graphic systems for performing data visualization using R. We should also be able to use ggplot two functions to plot common data visualizations, as well as be able to evaluate the visualization quality in answering a research problem by just considering the suitability of the chart, labeling, signal to noise ratio, and color choice, which are just some few criteria that would enable you to have a high quality visualization. So starting off, what is data visualization? Data visualization generally entails being able to represent just data in a graphical way using what are called visual elements such as charts, graphs, timelines, and maps data. And the benefit behind data visualization is that it provides the ability to act on emerging trends faster. You're able to visualize relationships as well as just patterns within a data set for whatever operations that you have within an organization. You're also able to understand customer trends quickly and efficiently, as well as be able to manage also business finances. So data actually cuts across all teams within organizations. What you see on your right is just a visualization of the CRISP DM process. It's a project methodology that normally data analysts or data scientists tend to use when it comes to just working on projects. And on the top you can see this business understanding. Normally that's the first phase. Data understanding is the second phase, and this is where we would be in a position to use or put into practice the skills that we are going to be learning. There's data preparation, where we prepare data as a result of just exploring and understanding our data. So in an effort to ensure that the data is in the right format for further analysis, whether it could be the plotting of visualizations, or whether it could also be generally maybe creation of machine learning models, etc. So that's generally where you would expect to be able to put into practice what we will cover in this particular workshop. Before going into data visualization, especially with R, it's important to have already covered a few concepts, or have already grasped a few concepts in relation to managing data. More specifically with regards to R, you should be comfortable working with the R programming language at a very basic level. We also have a course on that. If you feel like you need to work on that, you could always go through that, then later go through another prerequisite course, which we are going to talk about. So after you have gotten some good hands-on practice on the R fundamentals, the next thing that you need to do is to learn how to wrangle data using R. And that would include being able to handle, let's say, missing values, outliers, ensuring that the data set is clean. If there is any irrelevant data, you have already sorted that out. And as a result of all of that process, you might end up performing or using some of these functions that you see on your screen. That's a select function, filter, mutate, summarize, and group by functions. So generally, the idea is that you should be in a position to have already achieved or have already understood those concepts in relation to data wrangling. Even they actually also relate to data analysis before now going into data visualization. Again, the reason would be because if you want to create something like a pie chart, you need to create a table. And creating a table that's part of data analysis, you would end up probably using a function such as summarize as well as select to be able to create that table that would allow you to create a visualization. So those are just some prerequisites. So if you're not really familiar with, maybe this is your first time interacting with R, I would send you to just go through the the introduction to R programming course, and also the data wrangling with R course before now going into this particular workshop. Or you could also decide to also do another course also called data analysis with R that we also have. So yeah, so generally that is just something that you need to have in mind before continuing. When it comes to working with charts, so you want to represent data visually, we tend to use an approach that that works in many cases. Like for example, this particular illustration that I'm going to show you will actually help you be able to figure out how you can be able to select a chart. And it's an illustration by Dr. Andrew Abella that gives you an idea of where you can be able to use each chart or each type of chart, whether it's a pie chart, whether it's a histogram, whether it's a line chart, etc. And this is the chart itself. So we have chart suggestions. We have which, you usually start from the beginning. So what would you like to show in that visualization? Is it some relationship between the data that you have, like the different columns, which we normally tend to call them variables? Is that what you want to? If it's that, then you can opt to create a scatter chart if you're only working with 2 variables. But if you're working with 3 variables, if you want to show the relationship between 2 variables as well as another variable as well, and take into account another variable, then you can use a bubble chart. On the other side, if you want to display maybe something like a distribution of a single variable with just few data points, you can use a column histogram. With many data points, you can use a line histogram, etc. So the idea is that you can use this particular, I can call it a framework. We can call it a framework to just be able to choose the type of visualization that you want that would be much more suited for the use case that you have. I will provide this particular chart in the slides. If you're an Afterwork member, you should have access to it. So that's generally how you can be able to select and know when to use one particular chart over the other type of chart that you might have in mind. So going back and continuing from that particular bit in terms of best practices, so just to give you a good idea, yes, you can create a chart, but if you do not consider a few other things, such as how does a production ready chart look like? Of course, it needs to have labels. It needs to have a title. It needs to have axis labels. It could be the x-axis label and the y-axis label, so that the audience or the person who's reading, going through your chart, can be able to understand exactly what they are looking at, what data are they looking at, so that they're not misled or do not interpret the visualization differently from what was initially intended. So labeling is important. We'll get to see that in our practice work. There's signal to noise ratio, so ensuring that you do not add visual elements that aren't necessary to understand what is intended by the chart. So you might decide to maybe create multiple maybe line graphs within one particular line graph, and you could even have like 10 of them. But the question would be not line graphs, like you can have like just lines within a particular line chart, like 10 of them. But the question would be, wouldn't it be cluttered? Wouldn't it make sense for you to represent each line within its own chart? Or if you're looking to make comparisons, would it make sense to make comparisons or have two lines within the chart if you want to make a comparison? So signal to noise ratio is something else to consider. The other bit that's important to consider is color choice. You shouldn't have many colors within your chart. So if you have many colors, sometimes, actually colors mean something. You could have a brighter color that is different from the rest of the elements within the chart. And that could actually mean that you want a user to focus on that particular visual element that you have highlighted. Maybe if it's actually 2 line graphs or 3 line graphs, you have one that's red, these other ones are gray. Then in such a situation, maybe it could mean that you want the users to just focus generally on the one that's red. So that's also something else to note that you might also look into later onwards. When it comes to R, the different visualization systems, these are just approaches to creating visualizations using R, and these are just the basic visualizations that that's from bar chart, pie chart, histogram, box plot, I think I've mentioned line chart, even some other charts that we wouldn't have mentioned in this particular case, but we'll go into maybe even a heat map, etc. So there are different approaches that you can be able to use, and these are base R graphics, there's lattice graphics, as well as ggplot2, which we'll get to go through. Base R graphics system is just what is usually provided by default using the R language, and we tend to use high-level functions such as plot as well as lines. On the other hand, there's lattice graphics, which is a system implemented using what is called the lattice package, and it does not require high or low level plotting functions to customize the plot. The only thing is that if you have a lot of the biggest benefit is that if you have a data set that contains a lot of columns or a lot of variables, that's multi-dimensional data or high-dimensional data, then lattice graphics system can be applicable. Lastly, there's ggplot2, which is also a library by itself, and it allows us to create just graphs that enable us to work with just what is called univariate, which is just single variables or single columns, to be able to visualize that, as well as multivariate numerical and categorical data, like being able to also determine relationships between 2 variables or more and uncover findings as well as other findings. So yeah, so that's generally it with in relation to just a quick idea of what what data visualization with R entails from a theoretical perspective. The next thing that we are going to go through is now to go through the reading and the quiz that we've already shown you earlier. And the idea is that once you have gone through that, you should be in a good position to now get started with the practice work. You should take about 15 minutes to go through them. And once you're done, then we can continue from this particular point. All right, so once you have completed going through the reading and the quiz, the next thing that we need to do is to go through now the practice work. And before getting to start, it's important to note the following. We can, in order to work with R, we can use RStudio and also install R in our machines. But we're not going to do that because of issues. Sometimes you could get to experience or have errors while you're installing your RStudio instance or also just the R programming language. Instead, what we're going to be using is a cloud solution, which is just RStudio on the cloud, provided by, again, the providers of RStudio. And for this particular task, which we are going to undertake now, is now you're going to visit posit.cloud. That's the link on your screen, and sign up with, you can sign up with Google or something, whatever that works for you. So take like a minute or so to just go to posit.cloud and then sign up for an account there. And then once you have done that, then we can continue into our practice you can continue working on our practice work. So just do that and then we can continue. All right, so once you have done that, you should end up on this page. So once you've signed in, you should end up here. And the next thing that we need to do is to create a new project. So you click on new project, then new RStudio project, and you should be redirected to a new RStudio page. At the very top where you see untitled project, just click on untitled project and type in data visualization with R, and this should be the title of now the project that we are going to be working on, data visualization with R. And while you're doing that, RStudio on the cloud will be loaded, which is what you're seeing, which is just generally what you would have locally, but now you have it on the cloud. There are a few constraints or just restrictions with this particular using the cloud solution, which includes you cannot be able to have quite a number of projects. There's a limit of the number of projects as well as the processing power that you get to use. But for the purpose of going through this particular workshop, you shouldn't worry about that. We have already tested the platform and it should be good to go in terms of just being able to use R and going through the work that we have for today. So the next thing that we need to do once we have been able to get here is to just note the following. Over here we have a console, terminal, and background jobs. These are just tabs that we can use to just be able to possibly run some R code, or if even explore the system where this particular RStudio instance or RStudio program is running. So this, you can use it more like a terminal, like we would, like ls will actually display the files that are in here, which is project.rpg, and a visual of what is here is actually what is shown at the very bottom. The reason why we're not seeing our history, because it's a hidden file, but we are seeing project.rpg. Background jobs will just show you just the installation, the background processes for a particular installation that you might have. So over here, environment tab, you'll be able to see just the variables and their values, the ones that you create in your environment. History, you just give you just a history of the steps that you've taken in your work. Connections, if you want to connect to just external databases, etc. Tutorial, I think it's self-explanatory. The very bottom, this is where we're going to be importing our data. So uploading our files here, and be able to just manage them from here and also download them, etc. So those are just the main sections that you need to know. You could also, it's also important to note that we also get an editor on the top right that will show once we have been able to import a project, and that's where we will be able to import our we'll be able to write our code. So let's first of all, once we have gotten here, we should be good to go. In case you walk away, then come back and you realize you're not able to run anything, you can always refresh the page, and you should be able to just reset from where you had left off. Or what they usually do, the providers of POSIT Cloud, they also shut down the project so that it doesn't consume resources, computing resources, and then they turn it on when you want to use it. But you always have to prompt it by just clicking a resume button that they'll show you. So now the next thing that we need to do is now to download the practice markdown file. So there's a practice markdown file that we have provided. It's a practice resource, so just click on that and download it, which I am doing right now. It's going to download, and it has downloaded it. There's also the practice solution markdown file. I also download that, so 2 files that I'll download, and these ones will be downloaded into my downloads folder in my computer. Once I do that, I need to upload those files into this environment. So I'll go to the bottom right, and then I will go to upload, and then I'll choose the file. You can choose the individual file. So I'll click on the practice resource, the practice MD file. Then it will take a second or so to be able to upload. So I can just click on that, open, then okay. That's the first one. I can also upload the second one. You can always repeat this step if you realize that I'm moving fast. All right, once you have uploaded them, if you click on now the practice markdown one, it will open the editor. The editor will have just a tab. This is the first tab. And then what we have here is actually the content for this particular file. And the content is usually written in a language called R Markdown. So what I will do, I've already opened the first one. I can also open the second one by clicking on the other one, and it should open in a new tab as well. So we also prompted, when we click on this particular any of the files, we also prompted to install some packages that we will use. We need to install R Markdown, Reshape, Tidyverse, and we can click that that shortcut that we've been given here to just install them. So let's do that. And the beauty again is that you won't have experienced many challenges when that happens. So it's important that you take that into consideration if you're going to be working the cloud. But it doesn't mean you can't do it locally, but you can also do it locally. But just for learning, just use the cloud, because you won't get any sort of hindrances or in terms of obstacles along the way. So you can see behind, in terms of background jobs, this is actually what's happening behind the scenes when it comes to installations. So when you click also the same thing, you'll also get the same notification over here. You can always just click on it, but it's just going to repeat the same thing. But yeah, so as that continues, which is what we're seeing here, we can see the source. The source is now the code, the contents of this, the files themselves. And this is what we are seeing. The same case, if I click on the second tab, this is what I am seeing. So I just want to expand this so that I have some bigger space to be able to work with the editor. I'm going to click on this minimize icon over here. So you can see the minimize icon over here that you see. So I can click there. And now I have just my content. You can work with R from the code that the contents that you're seeing here. We have code, R code, which is enclosed in these delimiter characters. But alternatively, what we can do, So alternatively, what we can do is we can decide to visualize, to use the visual mode instead of just working with the source code or the source of the markdown files that we have. So you can click on the visual option, and it should change now your visual aspect, your visualization, you would get a prompt actually switching to visual mode. It just tells you that it's going to rewrite the entire content into just what is I'm using now, some feature called Pandox default, but it's okay, no worries about that. And now you should be able to see now our markdown file in an easier way. The same case, the practice work as well. You can the solutions, you can also do the same thing. By the way, if you do not have access to these ones, you will be able to get, if you're not an Afterwork member, you should be able to get the sample practice work that you can just walk through. But of course, if you become an Afterwork member, you are able to access all the resources that we are taking you through with. All right, so moving on, we'll go to the first practice markdown file. That's the first one, and we are going to go through now the examples, and then I'll let you go through the challenges by yourself. But you can always confirm the solutions by just simply going to the practice solution markdown tab and being able to verify. But just note that those are just sample solutions. So starting off, in order to work with ggplot2, which is the library that we're going to be using for data visualization with R in this course, we're going to install a set of packages called tidyverse packages, and these are packages that we can use for data science work. ggplot2 is one of them. So let's import that. Well, not import, but load that inside our markdown. And then the first thing that we're going to work on is just working on a bar chart. Before I even get to start going through the examples, it's important to note that when it comes to working with ggplot2, we tend to work with what are called layers. So you will note that I'll be referencing just the idea of layers. So for example, in order to create a visualization, you need to have a data layer, you need to have a visualization layer, like the visualization that you want. You also need to have a label layer, as well as other elements that you would get to work with, maybe a theme layer, etc. So starting off, in order to create a bar chart, but first of all, let's understand what a bar chart is. And it's a type of visualization that represents categorical data with rectangular bars, which would have heights or length proportional to the values they represent. So if you want to create a bar chart to show the distribution of total bill scores across the days of the week, this is what we are going to do. The first thing that we are going to do is just prepare the data set. Just install that. It does ask me to install something, but it's okay. No worries. So we are going to first of all load this data set that we have, which is actually what we are doing here. We're actually using the read CSV function from tidyr. You can use read.csv as well, which by default is provided by R, but this is from tidyr. The data set, we store it in tipsdf, and we view the first 6 records, and we see this is how our data set looks like. And these are the columns. So what we want is to create a bar chart to show the distribution of total bill of this particular variable, of this particular column. That's what we want to do. But something you will note is that we want to show the distribution of total bill across the days of the week. So you see that we have Sunday, we could have Monday, Tuesday, but we don't know which day. So we will create a summary table. That's when I was telling you about you need to learn about data analysis concepts. So this you would learn in a data analysis workshop, where we create a summary table, and we do that by simply referencing the data frame or data set that we had already imported, and then we use a pipe function to add now a particular operation that we want to apply to the data table, to the table that we have, the data frame. We'll call it a data frame because it's a tabular structure. And we will apply the group by function to group the records by the day. That's the day column. So we will group those records by the day column, and also create a new column called total bill, which will be a summary of the or to contain a sum of the total bill column. So for each and every day, we'll have, let's say, Sunday, Monday, etc. And then we will have another column, total bill. That's what we're going to preview. So this particular operation actually creates that table that has on the left hand side the day and on the right hand side total bill, and then we store that inside this particular variable tipsdf, and then we display that tipsdf table. And this is what we have now. And now we want to show the distribution of total bill. And now we're going to show, this is now our analysis, but now we need to visualize it. We're going to plot a chart. So the first thing that we need to do is, is define the ggplot function. And this ggplot function would take the data that we want to work with. So in our case, the ggplot function would take in the data frame that we want to work with, and then the function would take in now the specific definitions of where we want our data to appear. So we want on the x axis to have the day, and on the y axis we want to have total bill. And then that's the first layer. Then the second one, we use the geom_call function to create a bar chart. So when we're working with ggplot2, we tend to have just different functions for creating different charts. But for working with bar charts, we normally use geom, then call. Then we set the start parameter to identity, and then we can set the width of the columns that we want, as well as the color of that particular column. So note that for different types of visualization, the function here will be different. Then later we define, we say plus, then we define the labels, the title, as well as the x-axis and the y-axis label. And then lastly, we add a theme, which we just add some styles, like in terms of, for example, for the title, we want to ensure that it's centered. That's how we center it using the h_just parameter inside the element text. And when we set that to 0.5, we mean that we want to center the title, and also we set the size of the title as well as the font type, which is Times New Roman. That's what is now with regards to those are the settings for the plot's title. The next thing that we need to do is to that's for the title. The next thing is to now set for the styles for maybe the x-axis. So we want to ensure that the x-axis text is slanted 45 degrees in terms of it's rotated 45 degrees. We don't want to justify it or to center it. We just put it at 1, and let's run that. And this is what you have. So generally, you could just understand, try and study what you're seeing here and try and see what exactly we did here. And you can also play around by just changing a few values. All right, so once we have finished that, the next thing that we can be able to do is to go through now a vertical. So what we have here is a horizontal chart, a horizontal bar chart, but we can also create a horizontal or a vertical bar chart. The concept is actually the same. The only thing that we need to add is what is called a chord flip function at the very bottom. So we'll still prepare the data set just as we did, loading it to understand it, then creating the same summary table that we did earlier. Then after that, we can still use the same just set code that we had for data, geom call for bar chart, labels, theme, but now we add the chord flip function to be able to apply that particular operation that will result to horizontal. Is it horizontal? It's a horizontal bar chart. Initially, we had a vertical bar chart, so this is a horizontal bar chart. All right, so at this particular point, work on the challenge that we have provided and then verify your solution using the solution markdown solution that we gave you, and then you can continue. We can continue with the next step. All right, so the next thing that we need to do is to now go through the pie chart section. Now, pie chart is a type of visualization that shows the proportions or percentages between categories. by dividing a circle into proportional segments, and that's what we are going to do. There's an explanation here about how we have taken each and every step. The same case with the previous one, we had also provided some explanation before we got started, so you could always go through that if we are not able to go through a few things that you haven't understood. So the first thing that we need to do is just to prepare our data set, but before we do that, the idea is to create a pie chart to describe the distribution of Olympic gold medals. So let's prepare our data set, we load it. Then once we have loaded it, this is what we have. We want to create a pie chart for displaying the distribution of gold medals. So how we are able to do that, we will use the ggplot2 function to be able to define the data that we want. So Olympics DF is the data that we want, and here you don't have to even say data. You can always just remove even that. By default it would be the first parameter and it would be selected. So but I'll just leave it for just purposes of just giving you an idea. Then inside the s function, you would set this as nothing, the x variable. You don't have to set anything, but now what we want is to visualize gold medal, and that will be on the y parameter. Then we want to describe, we also want to set fill to be the country. So each color, each particular country will be assigned a particular color, if that works best for that. Not necessarily any. Once we have done that, but yeah, so once we have done that, by the way, before I even continue, just in the case of here, few just describes the categories for what we are going to be using, and we will use that to map the colors that we are going to be working with. So I had mentioned earlier, once we have defined our data, the next thing that we need to do is to get a function for creating the respective chart. When it comes to creating a the vertical and horizontal bar charts, we used geom_columns, col, and I think you can remember what we did. We used geom_col. Where is it? Geom_col. But now for pie chart, we normally use geom_bar. But again, we usually use it in together with now the chord polar function. So those are the two functions that we would tend to use when it comes to creating a pie. And what you will note, actually, what chord polar does is just converts the bar chart into a pie chart. So that's what generally what the chord polar function does. So once we have defined these two functions, the next thing that we need to do is to use the geom text function, and this allows us to add annotations to the different categories that we have. So inside our pie charts, inside each and every section, we will have some sort of percentage, and we use the est function inside the geom text to define the labels for those particular percentages. So for the label value, we are able to perform some calculation, and this will generally give us the percentage, the respective percentage for each and every category. So gold medal, let's say if it's for China, so it will be 56 divided by the total of the sum of gold medals times 100, and we want to display that in we don't want to have any decimal point places, and actually for one actually means we want to have one decimal place. So in our case, we want to have the one decimal place, and we set the percentage, which will be just the symbol that will come after that particular figure, and be able to also position where we want to have that particular that particular label appearing centered, which just means centered in this case. Then after that, we use the scale fill brewer to just be able to add a color theme to the entire chart, and there are different palettes that we can use. So this just gives us a theme that we can be able to work with. Then we set the labels for the chart. And then lastly, we use what is called theme void. And what theme void would do is just to remove the background. So the background that we have here would be removed, as well as grids and labels. That's what grid void does, theme void does. So if we run that, we should be able to see now our visualization. This is how our visualization looks like. All right, work on the challenge, and then once you're done, we can continue to histogram. Moving on to histogram, a histogram will just help us be able to display the distribution of an individual variable. And for our case, we are going to create a histogram to display the frequency distribution of the overall variable in the FIFA dataset, in this dataset. So if we run this, we should be able to see how the dataset looks like. So we have name, age. You can click on this arrow over here to just move on to the side. Overall, so you can see there's an overall variable that we're working with. So to work with a histogram, we again, first of all, use the ggplot function to set the data frame as well as the data that we want as to equal to age, and then that's the x on the x-axis for that, and then we use the geom histogram. And for histograms, normally you have bins, so we can define the bins that we want. We want 10. We also want to have this as the color of the different bins, and we can be able to also define the color specifically here. I don't even think this is necessary, but you can always just leave it out. And then we add the labels as well as define the theme for the style for the title, which you see here. And if we run this, we should be able to see our visualization, which we see here. So yeah, so that's our histogram. Let's see what happens when you remove that. So when you remove color, what happens is that the boundaries of the bars are removed, and we need them. So generally you can just set that here. All right, so work on the challenge, and once you've done that, then we can continue to line chart. So moving on to line graphs or line charts, we can use them to display quantitative values over a continuous interval or time period. And the idea is to understand trends, patterns, and also fluctuations in data over time. So let's create a line graph to describe the trend of gas price per gallon in Germany since 1990. So we are going to import the data set that we're going to work with. This is the data set. We have the year and the countries. Then we want to only work with Germany. So we are going to use the select function and have and we are going to select the columns that we want. We want here and also Germany. And that's what we want technically. So and we save that in Germany df. Again, if you want to go through more of these concepts in relation to selecting data, we have a course on that, data analysis, or even data wrangling. So we have here in Germany, and now we can now plot a line graph. So again, we use the ggplot. Germany, we set the data frame, and then we use the aesthetic function. And for x-axis, we set it to year. Y, we set to Germany. Geom line. Geom line, for geom line, we have this is the function that we would use for creating line graph, and we can be able to set it as shown. So we say the type of line that we want a dashed, the color of the line as well as the size of it. We also can be able to point, have points within the line itself, and we can set the color as well as the size of those points. And then labels as well as this theme, we're able to define different aspects about our chart or different elements inside our chart as shown, as well as lastly, we also are able to use the GM label to also define how we want to have our labels for Germany appear. So that's generally what we can be able to do. And let's run this, and you can be able to see, and you can also just play around with what you have. So the labels that you see, the geom label is actually what you see here, like this, the small rectangles that we have. That's what we see in this particular case. And that's what we set here. If we remove this, we shouldn't be able to see them. Did I run that? Yeah, so you shouldn't be able to see them, but I added them for just if you want to be able to just visualize them. All right, so that's the first example. For the second example, we can create a line graph to describe the trend of gas price per gallon in the US and UK. So we have two lines that we want to have. So we can load that to just see whether we have UK. So we have Mexico, we also have UK here. So we select the year, UK and USA columns. And then once we have done that, we can use now our approach ggplot. We select it. We set the data that we want, countries and the year on the x-axis, and then we set now the line, the geom line for one line. So this is for UK, and we describe how we want it. This will be on the y-axis as well. On the y, and we will set the UK to equal to the y parameter for the first line. Same case for the second line as well, and also set the type of line as well as the color, the labels, as well as the theme afterwards. So run that and you should be able to visualize your chart. All right, you can also just go through now the challenges, and once you're done, verify your solution and you should be good to go. Scatter plots are a type of visualization that we can use to detect if there's a relationship between two variables. So let's determine if there's a relationship between income and population variables. And if there is, you'll see some sort of, as the values of one particular values increase, the others will increase as well. So let's create that. Let's have that. So geom point is what we are going to use, by the way, to create a scatter plot. So we have selected that data. Okay, we can do that. There's a missing value here, but no problem. So we use the ggplot function to define the data we want to work with. On the x-axis, we want income, and y population. Use geom point for the scatter plot, and we set the colors as well as the size and label as well as the theme. And this is what we have. Technically, there isn't a relationship between the two because as the values of population increase, we don't have income increasing, so it's just stagnant. Or as income increases, the value of population don't increase, so it's just stagnant generally. All right, work on the challenge, and then we'll continue to heat map. So a heat map represents individual values or colors, and we can use a heat map to actually represent values. So what you have here, initially we had a scatter plot, but a scatter plot, we can define the extent to which these variables are correlated or have a relationship using a number. That number is usually between -1 and +1. And we can also use a heat map to be able to visualize those values. But in order to just start working on this, so to get to work on the creation of a heat map, we need to install what is called Reshape2 package that will provide us with a function called meld function that will allow us to create what is called a correlation matrix for the data that we have. And that matrix will just contain values that show us the extent of correlation between them. So let's click on that. And then once we have done that, we can now create a heat map to determine which variables are highly correlated. So we are going to prepare the data set. And then this is the actual data set that we had earlier. And then we want to work with Australia, Canada, France, Germany, Italy, Japan, and Mexico. We don't want year. So we want this data, and we also don't want missing values. So that's how we can also be able to set that. Then we create a correlation matrix. So we can be able to create a correlation matrix of the table here. So we have the degree to which values, which will represent the degree to which each and every variable is correlated with other variables. So that's what we're going to have here, correlation matrix. Now you can see Australia and Canada, it's 0.82, which is actually closer to 1. 1 is, it just means that they're highly correlated. But here, Australia, it's just the same variable, so it doesn't make sense. But Australia, Canada, these two are related. So it means as prices of Australia for fuel, is for oil, or is for gas, increase, the prices of also Canada increase. But for Australia and Japan, it's not as much. The same case with Canada and France, it's not as much. Could mean maybe there are incentives that the governments put in forth in order to cushion, in order to ensure that that doesn't happen. So that's a correlation matrix, but we can be able to show it in a heat map. But before we're able to show it in a heat map, we need to transform it into a format called a long form. And this is what the MELD function allows us to do. So we get the correlation matrix and we're able to put it in a long form, which is what we have here. We have variable 1, a variable 2, and a value. So Australia 1 point, and Canada, Australia 0.82, etc. Then we can use now, you can use ggplot to be able to plot now that particular function, that particular visualization. So we use ggplot to set the data that we want to, which is core df, that's the table. These are the variables that we want to work with, these two, and as well as the value to be able to be represented by the color of that heat map. We use geom_tile for now being able to represent the for the heat map, and geom_text to be able to add text to the different tiles within, or different boxes within the heat map. And we also use chord fixed, and chord fixed, as earlier we mentioned, it just sets the tiles to be squared. You can have just different types of tiles in relation to a heat map. We also use now scale fill gradient to just set that for values that are closer to -1, we want them to be blue. For values that are closer to red, we want them to be 1. For the mid ones, we want them to be white. And we also set the theme here. So if I run this, I should be able to see a heat map that will be able to help us just visualize the relationships between the variables. So you can see the ones that are closer to +1 or 1 are actually highly correlated, like this Italy and Australia, or Canada, Australia, Italy and Australia here. So I think you get the idea. All right, so work on the challenge, and then once you're done, we'll work on the last visualization and type of visualization, and then we'll continue to the next steps. So a box plot, which is what we are going to cover, is a type of visualization that allows us to display the distribution of data, and we can use it to detect outliers, compare distributions, even just be able to show the shape or this the central tendency or variability of data. Starting off, we can start off by, first of all, we are going to create a box plot to determine whether the spirit servings variable contains outliers. So that's what we're going to create. And let's prepare the data set. That's what we have done. And you can be able to see that this is our data set that we are going to be working with: country, beer servings, as well as spirit servings that we are going to be working with. All right, so moving on, so we are going to use ggplot to set the data that we have, as well as the data that we want to work. We want to work with spirit servings, and so that's what we want to create a box plot for. We use the geom box plot function to be able to create a box plot for that. We want the color inside to be red, outliers, if there are any, to be displayed using this color, and also the shape of that outlier. It could be a circle, and yeah. So start box to be able to display the whiskers. These are just the ones that are usually on the side of the box plots. scale X discrete to be able to define the size of our box plot. We wanted to make it smaller. We add labels, also set the theme, and also we also did set the theme classic, but we also wanted to also add our own theme later, and also we set the box plot to be horizontal one using ConFlip. And generally that's it. That's what we would get here. We have a box plot, and there are some outlier values which we have here. If we want to compare the distribution of income across continents using a box plot, again, we can be able to do that. Let's just display the countries again to be able to see how that looks like. So we can use the ggplot function to be able to define the data frame we're working with. But now we want to have distribution of income across continents. So continents, we set it at for the X parameter, for income, Y, and then color to be continent. Then we just we work with the same functions that we did before, and then we plot our function, and we should have multiple box plot for just that particular case. But across each and every country, continent, we have now income, and you can see that there are outliers within those particular cases. All right, so this particular point, at this particular point, just work on the challenge and then verify your solution, and then we'll continue. Okay, so moving on, the next thing that we're going to do is to now go through the project that we have provided. So there's a project that we have provided. This is an opportunity for you to put into practice what you have learned so far in relation to data visualization with R. Go through the project, and then once you have gone through it, you can check out the solution that we've also provided to just see whether you would have been able to have achieved what was the expectation. And once you're done, that will be it for this particular workshop. The next step in terms of going through now this learning journey would be to now looking into maybe machine learning with R, or even just doing statistical data analysis with R, because the concepts that you will have learned will be important in those areas. So yeah, so that's it with regards to this particular course. If you did like it, you can always give it a thumbs up on YouTube or the platform that you're watching from. And all the best, and see you in the next course. See you then. Bye-bye.